Hey folks, I welcome you all to this live session on Introduction to Neural Networks. Now, I'll just wait for some of the other folks to join in and just let me know if you guys can see my screen and if I'm audible to you folks. Just give me a quick confirmation in the chat. Until the other folks join in, I'd like to tell you about Great Learning Academy, which is a free learning initiative by Great Learning, where we have more than 100 courses. And these courses are with respect to data science, artificial intelligence, statistics, digital marketing, cloud, and a lot more. And all of these courses have been taught by industry experts who have their master's degree or their PhD from Ivy League schools. And the best part is once you complete these courses, you will have a course completion certificate and you can go ahead and add that certificate onto your LinkedIn page or onto your resume, and that will be a huge value add for you guys. So you can get the link for GLA in the chat. And also, if you're interested to learn through an app, then we also have the Great Learning app. So you'll also find the link for GL app in the chat. So if you have any queries with respect to Great Learning Academy as well, you can go ahead and post it in the chat. We will take them up. Now, also to some of the folks who are new to our channel, so I'd like to tell you guys that we are an edtech company where we upload a lot of videos with respect to different domains, and all of these videos are free. So if you go ahead and hit that subscribe button and click on the bell icon, you'll be able to watch all of our videos and you'll get a notification whenever we are live. So that would also encourage us to come up with more such live sessions. Now, what we'll do is before we start off with the session, so before we actually understand what exactly are neural networks and what exactly is deep learning, my first question to you guys would be, what is intelligence? Or in other words, can you guys tell me what is it that actually makes humans intelligent? I'll wait for you guys to answer in the chat. What do you think? So there'll be a 15-second delay between my stream and over here. So think about it. What is it that actually makes us intelligent? Nightblaze says mind. Hitesh says brain. Basdev says using your IQ to the most. Umadevi says ability to think and take decisions. Bhavesh says brain again. Skill, mind neurons, think and solve problems, thinking capacity. Well, all of you are right. And as someone has said, it's the ability to make decisions. That is what actually makes us intelligent, isn't it? So, if you combine all of these three, we as humans, we are intelligent because we can learn. We can learn on a continuous basis, right? So, from our kindergarten days to our degree, we are continuously learning. And also, once we learn, it just doesn't stop at that. We apply our brain to actually think on what we've learned, isn't it? So let's say if we've learned some numbers, if we've learned the numbers from 1 to 10, then we actually use our brain to think and actually understand what is 1 plus 2 or what is 3 plus 3. And also, once we learn and think on the basis of what we learn, we can also make decisions. So when you combine all of these three, that is exactly what makes us intelligent. Don't you guys agree with this? Dipesh says it's smart work. Darbar Chanda says the thinking and implementation of human being. That is true. So now that we know what is it that makes us intelligent and why humans are intelligent beings, now let's actually change the question a bit over here. Now let's say if you find a machine which can show human-like intelligence, that would be truly awesome, isn't it? And this is what artificial intelligence is all about. So if you can actually find a machine which can learn like human beings, which can think like human beings, and which can make decisions like human beings, that is what artificial intelligence is all about. And to simply put, the definition of artificial intelligence would be it is that domain of computer science where we actually teach machines or computers to think like humans. As simple as that. Now, there could be a lot of applications of artificial intelligence. If you take Siri, what exactly is Siri? It's a chatbot, isn't it? But what you're actually doing is you are speaking to a virtual machine. Now, when you speak to a phone, what you're speaking is actually called as a natural language, right? But that natural language, how is a machine able to understand the natural language spoken by human beings? Because Siri is an intelligent machine. Now, similarly, we have something known as smart cars, or we have self-driving cars, right? So self-driving car is able to go straight or maybe take left or take right, and whenever it sees a barricade, it stops on its own. All of this, the Google self-driving car or maybe Tesla self-driving car, all of these are able to do it by themselves because these machines have the capacity to think for themselves. They know that, let's say, if there's a barricade and right in front of me, and if I go and hit that barricade, there'll be an accident and I'm not supposed to do it. So this is how the machines think like humans. And now that we know what exactly is artificial intelligence, let's look at the subsets of artificial intelligence. So under artificial intelligence, we've got machine learning, and in machine learning, we've got deep learning. Now, as I've already told you, artificial intelligence is basically that domain of computer science where we teach machines how to show human-like intelligence. Now, there are two ways to achieve artificial intelligence, and those two ways would be machine learning and deep learning. Now, let's start off with the first one, which is actually machine learning, and we'll understand the example of machine learning with this particular example over here. So what do you see over here? What exactly is this? It's a simple pen, isn't it? Now, what about this? Well, this again is a pen. And this? Well, this too is a pen. Now, how do you actually know that all of these are pens? Well, because you would have, as a kid, come across a picture of a pen and you would have been told by your kindergarten teacher or your parents that this is a pen, and your brain learned that whatever looks like this is actually a pen. Now, what your brain is actually doing is, this is where the learning component comes in. Your brain learns all the features associated with these pens, and you are training your brain to learn these features. And that is how our brain functions. But what about a machine? How can I train a machine to learn? Now, let's say I was shown a picture of a pen. As a human being, if you're shown a picture of a pen, or maybe you're shown a real life pen, you would immediately recognize that it is actually a pen. But on the other hand, if I feed in an image of this pen to this machine, how will this machine be able to identify that this actually is a pen? So this is where machine learning comes in. So as our brain was trained, as we had trained our brain, our brain learned that a pen looks like this. So that is what we will do with a machine as well. So we'll take all of these images of pens and we'll keep on feeding them to this machine until it learns all the features associated with these pens. And once it learns all the features associated with them, so this is what we call as the training phase. So once the training phase is done, we go ahead to the testing phase. So here what we're doing is we are giving it a new image over here. So as you see, we've got these three pens, and this is a completely new object over here. And we are giving this completely new object to this machine. Here we are trying to find out if this machine is able to identify this as a pen or not. And if this machine is able to identify this as a pen, then we can correctly say that the training has been done properly. On the other hand, let's say if it tags this object as a pencil or maybe as an eraser, then the training is not really perfect. And this is the underlying concept of machine learning. So what we basically do is we train our machine, or we train our model on top of the raw data, and once the training is done, we give it test data to to determine how much it has learnt. So that was the basic gist behind machine learning. Now we'll look at the subsets of machine learning. So broadly, we can say that machine learning is comprised of supervised learning and unsupervised learning. We also have another branch called as reinforcement learning. Now, reinforcement learning will not really look at today. So again, also even with respect to supervised learning and unsupervised learning, I'll just give you guys a gist. So in supervised learning, we have labeled data. That is, data will have some tags associated with it. And in supervised learning, what we do is we try to find out what is, we either have algorithms such as classification or regression algorithms, and we apply these classification or regression algorithms to predict or classify something. But when it comes to unsupervised learning, we have unlabeled data. Now, when we have unlabeled data, the only thing which we can do is understand the underlying structure of the data. So in unsupervised learning, we have algorithms such as k-means, principal component analysis, and factor analysis. And these are some things which we do with unsupervised learning. So guys, just let me know if we are clear till here. This was the basic gist of artificial intelligence and machine learning, and how machine learning is just a subset of AI, or we can also say that machine learning is a way to achieve artificial intelligence. Now, uh, we'll come to deep learning. So when it comes to deep learning, it again is a subset of machine learning. So there would have been some sort of some tasks which a machine learning algorithm was not able to achieve, and this is where deep learning algorithms come in. So what exactly is deep learning? So simply put, deep learning is used to develop intelligent algorithms which mimic the human brain. Because as some of you guys had said, that it is our brain which makes us intelligent. Now if we have to make a machine intelligent, all we have to do is create algorithms which can mimic human brain. Now once we know that, the next question is, how do we mimic human brain? So if we have to mimic human brain, then we actually need to know what is our brain composed of. So our brain is actually composed of neurons, isn't it? So we'll just have a 2-minute biology lecture over here. So this is how a neuron looks like. So we have something known as a dendrite, a nucleus, and an axon. Now when you look at the dendrite, so this dendrite is where you collect all of the information from. Now also, if a person has to communicate or if a person has to think, then these neurons pass on electrochemical signals to other neurons. So that is the basic idea between how we think, or how we communicate. So these neurons help in transferring electrochemical signals, and these dendrites which you see help in, they act as receivers of those electrochemical signals. Now once the dendrite receives those electrochemical signals, they can be processed here in the nucleus. So here what you see, this is the cell body. Inside the cell body we have the nucleus. Now the electrochemical signals are processed inside the nucleus, and the processed information is passed on through the axon. So what you can say is, there are basically 3 layers. First is known as the input layer, which is the dendrite. Next we have this hidden layer. Let's call this a black box. Now this black box comprises of a nucleus which processes this raw data, and that processed information is passed on through these axons. So this is the output layer. So this is how a biological neuron looks like. And if we have to create intelligent algorithms, we would have to mimic a biological neuron. So this is where we will go ahead and create an artificial neuron. And this artificial neuron is known as a perceptron. So similarly, as this biological neuron had input, a processing layer, and output, here we've got this input layer, we've got this processing layer, and we've got this output layer. And once we have that, that was just a single neuron. Now if you look at your brain is composed of millions of neurons, isn't it? One neuron doesn't make up your brain. You'll have lots and lots of neurons. Similarly, if you have to create an artificial neural network, we would need basically a collection of all of these neurons, and this is what we'll have as the final result. So we'll have something known as the input layer, where we'll have all of these neurons, then we'll have these hidden layers over here, and then we'll finally have the output layer. So let me just go ahead and see if there are any questions. So guys, let's make this session very interactive. If you have any doubts anywhere, you can go ahead and ask them in the chat. I'll take them up. Mandar is saying artificial neuron is known as perceptron. Yes, that's right. So in deep learning, terminology, you can call an artificial neuron as a perceptron. So this is what is known as an artificial neural network. Now that is also clear. What we'll do is we'll understand why do we actually need deep learning. So as we know, deep learning is a subset of machine learning. That would mean there would have been some limitations of machine learning. Now, one simple limitation of machine learning is it can not work on a large data set. So let's say when you talk about in real life industry problems, you would have data which is in petabytes or exabytes. Now to process all of that information through a simple machine learning algorithm will not be possible. So and also another limitation when it comes to machine learning is manual feature extraction is not possible. So let's say if it's a simple image classification problem and we have this image of an owl over here. So if we have to come up with a solution for this image classification problem, then we'd have to train our ML algorithm, and to train that ML algorithm we would actually have to manually extract the features and feed it to this ML algorithm. So let's say we will feed this ML algorithm that owl has two eyes. It has a beak shaped like this. This owl only has three legs. This owl is sitting on a pencil. This has pointy hair like the devil. So all of these features we will have to manually extract. And when you talk about image classification, let's say if you have a huge image, a very large image, then you'd have to manually extract all of the features and feed those features to a machine, which is a very time consuming and a very strenuous task. So this is the this is the limitation of machine learning. So what happens in deep learning is this manual feature extraction is replaced with automatic feature extraction. And in deep learning, since deep learning is implemented through neural networks, these neural networks are able to learn or able to extract all of the features of this owl by itself. So what it'll do is it'll draw a boundary around maybe the maybe the eye of this owl or maybe the beak of this owl, and this neural network will automatically learn how the eye looks like, how the beak looks like, or maybe how these legs look like. So this is what is known as automatic feature extraction. Kumar Govind, so let me just go ahead and take up some more questions over here. So keep up your questions now, I'll just take them up. Kumar Govind is asking, is the hidden layer processing unit? Yes, all of your processing happens in the hidden layer. So you have a lot of activation functions and you have optimization functions over here which take care of the processing. Anil is asking, why do we need deep learning? So as I've told you, there are certain limitations of machine learning, and because of those limitations and because of the advantages of neural networks, we would prefer deep learning algorithms rather than machine learning algorithms. Knight is asking, is each neuron contain data of machine learning? That would actually depend, Knight. So let's say let me go to the previous example over here. So we've got the input layer, hidden layer, and the output layer. And now we've got these three neurons over here, and this particular neuron, this is taking the input, this is taking the input, and this is taking the input. But when you talk about this hidden layer, along with this input, it will also have something known as an activation function, and that activation function is basically multiplied with something known as a weight. So we'll understand all of that when we'll go through the next set of slides. So we've got manual feature extraction, we've got automatic feature extraction. Riti is asking, does it use any language? So to implement neural networks, we mostly use deep learning frameworks such as TensorFlow and Keras, and these can be implemented in both Python and R, but the most widely used language is Python. Viral is asking how to make AI assistant. So we'll actually have a live session on this, on how to make a chatbot. So you can attend our live session. You can actually go ahead and check out Great Learning Academy, where you can just check out the next set of live sessions which are going to come up maybe in this week or the next week. Riti is asking, in which language are the neural networks written? So as I've told you, neural networks can be implemented with either Python or R. So language that is totally dependent on you. It's not necessary that you would have to learn Python itself to implement neural networks, or there's no hard and fast rule that you would have to either learn Python or R to implement this. The important point to understand over here is that you have to understand the underlying concept of a neural network and the mathematical concept of a neural network. Then you'll easily be able to implement all of them in either Python or R. Anil is asking, is feature selection the only challenge, or there are other challenges as well? So manual feature extraction is one of the challenges. The next challenge would be it doesn't really work properly on a huge data set. And then also it is, if when you talk about ML algorithms versus deep learning algorithms, ML algorithms turn out to be, they would need much more processing power than what a deep learning algorithm would require, and also they're more time consuming than a deep learning algorithm. So considering all of these limitations, we prefer deep learning algorithms over machine learning algorithms. Knight is asking, do we need a lot of mathematics skills? So when you talk about neural networks itself, so you would have to understand the basics of linear algebra and differentiation, because differentiation especially is used a lot in neural networks. And when you talk about ML in general, then you would have to know the basics of stats and the basics of numerical computation and metrics computation. Right, so I guess we are done with most of the questions. I'll take up the rest of the questions later on. And to the folks who have just joined, I'd like to tell you that today's session is on neural networks. So, you can, if you've just joined, you can just sit through the session because I'll be covering most of the things today. And also, if you want to learn AI or ML comprehensively, then you can check out our courses on Great Learning Academy. You will find the link for it in the chat. And also, if you want to learn through an app, we also have the Great Learning app. You will find the link for that as well in the chat. And if you, I request you guys to go ahead and hit the subscribe button and click on the bell icon, as it will encourage us to come up with more such live sessions. You can also go ahead and tell about Great Learning to your peers or to your friends, as it will help them to be more productive in this lockdown. So I'll take up the rest of the questions later on. And now that we know why do we need deep learning, let's understand how exactly deep learning happens with an artificial neural network. So we have an input layer, we have a processing unit, and then we have an output layer. So as you see over here, let's say we've got 10 inputs or maybe n inputs. We've got x1, x2, x3, and this goes on till xn. Now, each of these inputs is actually multiplied with a weight. So, x1 is multiplied with w1, x2 is multiplied with w2, x3 is multiplied with w3, and this goes on till xn is multiplied with wn. Now, this basically becomes x1 w1 plus x2 w2 plus x3 w3 till xn wn. Now, once you do that, you basically have a linear equation. Now, to that linear equation, you add something known as a bias. And once you add all of this, so once you add the multiplied sum product of the inputs and the weights, and then you add the bias to it, you have to pass it through an activation function. because most of the real life problems, those real life problems are not linear, and if you have to convert a linear problem into a non-linear problem, or maybe if you want a non-linear solution, you'd have to pass this linear equation through an activation function, and this will give you the output. Now let's actually see what exactly is happening inside this perceptron. So let's say we've got these three inputs right now. We've got x1, x2 and x3. Now these three weights are randomly assigned to the inputs. So 0.5 is a weight which is randomly assigned to input x1. Then we've got 1.2, which is the weight randomly assigned to x2. Then we've got 3.7, which is the weight randomly assigned to x3. Now, once we have these inputs and the weights, we just multiply the inputs with the weights. So we get x1 into 0.5 plus x2 into 1.2 plus x3 into 3.7, and then we add the bias to it. So this is what is happening in the first layer. Now after this, let's actually understand why do we need weights. Right, so I have a question. Is bias a random number? So let's actually understand the importance of bias and weights over here. So why do we need bias and why do we need weights? So when we talk about bias, so consider this neural network in a three-dimensional space with the x-axis, y-axis and the z-axis. And if you have to shift the neural network in the three-dimensional space, so let's say the current position of this neural network, or maybe one particular point in the neural network is 0, 1, 0, and you'd have to shift it. That is when you'll go ahead and change the bias. So you can consider the bias to be, let's say, if you talk about a simple equation of a linear line, the equation of a linear line would be y equals mx plus c, isn't it? Now when you take this to another dimension, so linear equation has only two dimensions, x and y, but when you add one more dimension to it, you will also have z. So here that bias acts as c in your linear equation, and that helps you to move your neural network through the three-dimensional space. So now that is what we know about bias. Now let's see what is the importance of weight. So I've told you guys that the weight is initially randomly assigned. So here we are trying to solve a problem statement which actually goes like this. So let's say you have an exam tomorrow, and the question is, will you be able to pass the exam if you wear a red shirt? So here we have two inputs. One input is you have to study if you want to pass the exam. Second input is you would have to wear a red colored t-shirt if you have to pass the exam. Now both of these are very interesting inputs, isn't it? So we know that to pass the exam we actually have to study, but wearing a red shirt has absolutely no relation with passing the exam. Irrespective of whatever color you wear, blue, red, white, yellow, if you don't really study for the exam, you can't really pass it. So here what we have is we've got x1, x2 denoting these two inputs, and we've got w1 and w2. So here these w1 and w2, it denotes the relative importance of the weight. Now what is going to happen is initially these weights are randomly assigned, but after the first iteration it will get an error and it comes back, and once it knows that what result we've got is actually not right, then the weights are going to be changed, or the values of these weights are going to be changed in such a way that w1 is going to have much more weightage than w2, or you can say that x1 will be more important than x2. So this is why we need weights. So I hope everyone is clear on why do we need bias and why do we need weights. So if you have questions, you can post it in the chat. Hitesh is asking, is AI just neural networks? As I've told you, AI, now the simple definition of AI would be implementing or basically creating machines which can show human-like intelligence. That is a simple definition. Now, a simple example of artificial intelligence is, let's say, fraud detection, or maybe so let's say if you done let's say you suddenly get a message on your phone stating that
there has been a transaction of 1 lakh rupees and you've bought a diamond necklace in Canada, but you've never been to Canada and you've never really spent more than maybe 10,000 rupees at one go. So this comes totally as a shock to you. But your bank was able to identify this as a fraudulent transaction and it immediately sent you a message. So this is a case of artificial intelligence. So here what is happening is your bank, it keeps a track of all of your transactions. So it knows that you've never been out of India, you've never spent more than 10,000 at one single go. So when your bank suddenly sees a transaction in Canada which is worth 1 lakh, that is an anomaly and it flags it off, and it immediately, your bank immediately sends you a message, or maybe you'll get a call from one of the representatives from the bank asking you if you actually made this purchase. So this is what we call as artificial intelligence, and this artificial intelligence can be implemented through either simple machine learning algorithms. So here what we do is, let's say in the banking scenario, you can just have one final column which would tell you whether the transaction is fraudulent or not, yes or no. So for this particular example, this just becomes a classification problem. Now let's say if there are a lot more factors involved, then in that case your machine learning algorithm will take up much more time and it will need much more processing power. So that is why we'll go ahead and use neural networks for this purpose. Saujanya is asking, how does it know that W1 should be more than W2? We'll actually cover that. So for now, just understand that initially these weights are randomly assigned, and when we go forward, we'll get a result. Now that result is tallied with a result which we already have, and if we get high error, then we come back and update these weights. So this is what happens over here. Mohammad Zoeb is asking Hindi mein class kab hogi, so we'll be conducting live sessions in Hindi as well. If you want to know when exactly is the next Hindi session, you can check out Great Learning Academy. There you'll have the list of all of the live sessions coming up. Right, so this is the importance of biases and weights. So once this is clear, we'll understand the perceptron training algorithm properly. So we had all of these inputs with us, x1, x2, x3 going on till xn, and we had multiplied these inputs with the weights. So x1 into w1 plus x2 into w2, and it goes on till xn into wn. After that, we will pass it through this. So this, what you see, would be your hidden layer. Here we'll add this bias to the addition of all of this. So that will become x1 plus w1 plus x2 plus w2 till xn wn plus bias. That will pass into the activation function, and then we'll get a result. Now what we do is, since this part is what is known as forward propagation, and in forward propagation we are actually training our machine, or we are training our computer on top of the data. Now we would already have the right result with us. So we compare the result or the output given by this neural network with the observed output. And when we do that, we will get an error. Getting an error is there's a very high likelihood of getting an error in the first forward propagation, because all of these weights are randomly assigned. Now once we get the error, we go back and we update these weights. Now after we update these weights, we again go forward and then we'll see what is the result. Again, let's say if there is high error, we go back and then update the weights again. Now we'll see what is the error. So this process goes on until we have the minimum error, and this is what is known as training your neural network. So the process of forward propagation and back propagation keeps happening until we reach the stage of minimum error. Ravi Shankar is asking, do we need EDA in this case, as feature selection is automatic in ANN? That's a very interesting question, Ravi Shankar. So Now, training the model is different and exploratory data analysis is totally different. Now, if you have to, let's say, even if the neural network model is able to extract all of the features from the data by itself, but it needs to be given a tidy data, isn't it? So let's say if you totally have an unstructured data set, and let's say if you have a data set with a lot of missing entries or maybe a lot of outliers, then even though your machine or even though your neural network is able to extract all of those features, you will get an incorrect result because the data itself has a lot of inaccuracies in it. The data itself is not consistent. So EDA should always be your first stage or first step in machine learning or in deep learning. And that is why, as you know, if you have learned a bit of machine learning, then it should be clear to you that around 50% of the time that a data scientist spends is in exploratory data analysis. So whatever data you actually extract or whatever data you're working on, you have to make sure that this data is perfect. This data has no inconsistencies present in it. This data has no outliers present in it. And once you make sure that your data is tidy, only then you can go ahead and build your machine learning models or your neural network models on top of it. Riti Singh is asking about how many iterations do we need for 100% accuracy. Riti Singh, to answer that, 100% accuracy is never possible. So you can take it in writing that if you actually build a machine learning model or a deep learning model with 100% accuracy, then that is actually magic. You can actually, so let's say if we have a machine learning model or maybe a deep learning model which can correctly predict if the stock price is going to rise or if the stock price is going to fall, then you can basically rule the stock market, isn't it? So you can never build a model which is 100% accurate. So especially in the industry, if you actually get a model which is around 85% accurate, that is considered to be a very good model. Nitish is asking, bias is the number which is added to the input in the hidden layer. Yes, that is true. Riti is saying, so can we say that data analysis is the most important part? I mean, all of the parts are equally important. It's just that when it comes to exploratory data analysis, you would have to spend a lot of time because if the data is incorrect, the results are incorrect. So let's say if you just have a tidy data set and then you build incorrect models on top of it, again, you'll get an incorrect result, right? Even though your data is 100% correct, but if you go ahead and build wrong models, or maybe if your hyperparameters are not set properly, or maybe if if you built a wrong algorithm on top of the data, then even in that case, you will not get the right result. So I hope this is clear as well. So guys, this brings us to the end of this session on introduction to neural networks. So if you have any questions, I'll just take them up. We'll have a quick Q&A session now. And then after this Q&A session, we can just say adieu today. So again, just a quick information to you guys. If you don't yet know what exactly is Great Learning Academy, we have launched this free learning platform called GLA, where you have almost 100 courses with respect to artificial intelligence, with respect to machine learning, data science, statistics, digital marketing, and a lot more. And once you complete these courses, you will have a course completion certificate, which you can go ahead and add it onto your LinkedIn page or onto your resume. And also, so to get the certificate, you would have to complete, so some of the courses would have maybe assignments, some of the courses would have quizzes. You have to complete those and you'll get the certificate, and all of these are absolutely free. Priyadarshini is asking, do you provide e-certificate? Yes, you will get the e-certificate once you complete the courses over there. So I would request my team members to put the link of Great Learning Academy over here in the chat. And also, if you're interested to learn through an app, we also have the Great Learning app. You can check that out. And for all those folks who are new to our channel, I'd request you guys to subscribe and hit the bell icon, as you'll be notified on our next set of live sessions and the next set of videos which we are going to upload soon. Reeti is asking, will we get any certificate for these webinars? So if you attend this webinar, then you will not get the certificate. So for you to get the certificate, you would actually have to complete any of the course which is present on Great Learning. Mandar is asking, please explain with one more simple example of artificial neural network. So which part do you exactly want to understand? Do you want to understand this perceptron training algorithm? So let me actually take an example over here. So let's say if we want to predict, so let's take this example. So let's say the problem statement is what would be the GRE score of a student if his CGPA is 8.32. So here your dependent variable is the CGPA. Here the dependent variable is your GRE score and the independent variable is your CGPA. So here, now let's say you already have an observation over here. One of the student, or maybe two students whose CGPA was 8.32, their GRE score came up to be 325. Now, what we're going to do is, let's say I'm going to take a new student whose let's say CGPA is exactly 8.32, and we would want to know how much GRE score would he get. So now let's say we have that input fed to this network, we go forward, and then this neural network predicts a value of, let's say, 250. Now, the actual value for a CGPA of 8.32 should be 325, but this neural network has predicted a value of 250. So here we know that there is an error. So we go back and then we update the weights. Now after we update the weights, again we forward propagate and then we get a result. Now let's say if the result this time becomes 125. Now the result becomes 125, the error has increased even more, isn't it? So then the neural network understands. So this is where the automatic feature extraction comes in. So here the model itself understands that this is not the right direction which I should go in. I should actually, let's say, instead of decreasing the weights, I should maybe increase the weights. So it increases the weights and then it goes forward. And after this, let's say it gives out a result of 300. So now it knows that it is going in the right direction. Again, it goes back, it updates the weights and it gets a result of 320. So this process goes on until it gets or until it has the least accuracy possible. So I hope this helped you in understanding how the perceptron training works or how forward propagation and back propagation works. Arti is saying, will you provide more lectures on neural networks? Sure, there'll be a lot of sessions on deep learning and AI. Arti is saying, will you continue this lecture after for more levels? So this session is only an introduction to neural networks and deep learning. We'll have more sessions. So in those sessions, maybe we'll have a coding with Keras or TensorFlow as well. And then we'll take a data set and we'll implement all of these on top of the data set. So guys, if there are no questions, I'd like to take the leave for today. And thank you very much for attending the session. Hope you have a great day ahead. So this will be it from my side, guys.